Look up on a clear night, and the sky already seems endless. But nothing you have ever seen, nothing any human being has ever seen, comes close to the true scale of the universe. In the next few minutes, we are going to travel outward together, step by step, until the earth beneath your feet disappears into nothing at all. Be warned. By the end of this journey, you may never feel quite the same size again. Let us begin here, at home, the Earth. Around 8,000 miles across, and to us, unimaginably vast. Every mountain, every ocean, every war, every love story, every person who has ever lived, all of it has happened here, on this single pale blue dot. Hold this image in your mind for a moment. It is the last time our planet is going to look big. Our moon orbits about 250,000 miles away. That sounds close. But you could line up every other planet in the solar system, side by side, in the gap between the Earth and the moon, and still have room left over. Even at this very first small step, the distances are already far stranger than they appear. Now turn toward the Sun. It is so large that 1 million Earths could fit inside it. If the Sun were an ordinary front door, the Earth would be a single grain of sand resting on the doorstep. And remember this as we go, the Sun is not a large star. It is a middling, average one among hundreds of billions of others. Light is the fastest thing that exists, crossing 186,000 miles every second. Sunlight still takes 8 full minutes to reach us, which means you never actually see the Sun as it is right now, only as it was 8 minutes ago. Already, just by looking up, we are staring into the past. Even our nearest planetary neighbors are worlds away. A radio signal to Mars can take 20 minutes to arrive. When we drive our rovers across its surface, we are always steering a machine as it was a third of an hour ago. And Mars is practically next door on the scale we are about to explore. Push outward now, past the asteroid belt to the giant worlds, Jupiter, Saturn, Uranus, and Neptune. Out here, sunlight is faint and cold, and a single orbit can outlast a human life. Neptune takes 165 years to circle the Sun just once. It has completed only a single orbit since the day we discovered it. In 1977, we launched 2 spacecraft, Voyager 1 and Voyager 2, on a one-way journey out of the solar system. They are the fastest and farthest human objects ever built. And after nearly 50 years of unbroken flight, they have only just crossed the boundary of the Sun's influence. At their speed, reaching the next star would take some 70,000 years. And even the planets are not the true edge. Far beyond Neptune lies the Oort Cloud, a vast shell of frozen comets that may stretch nearly a full light year out from the Sun in every direction. Our solar system does not end at the last planet. It ends somewhere out there, in the cold and the dark, halfway to the stars. Here, ordinary distances collapse, and we need a new ruler entirely. The light year. The distance light itself travels in a single year, nearly 6 trillion miles. On this new scale, the entire solar system, everything we have just seen, shrinks down to a single, almost invisible point of light. The nearest star to our Sun is Proxima Centauri, just over 4 light-years away. That is our closest possible neighbor. To picture the emptiness, imagine the Sun as a grapefruit sitting in New York. Proxima Centauri would be another grapefruit, all the way over in California. And between those 2 pieces of fruit, almost perfectly empty space, and stars come in sizes that shame our Sun. Betelgeuse, the red shoulder of Orion, is so vast that if you placed it where the Sun is, its surface would swallow the orbit of Jupiter. Larger still is a monster called UY Scuti. Our Sun, beside it, becomes a single, barely visible pixel. Now pull back far enough to see them all at once. Our Sun and every single star you have ever seen with your naked eye belongs to one vast island of stars, the Milky Way. A slowly spinning disk of somewhere between 100 and 400 billion suns. The Milky Way is roughly 100,000 light-years across, which means light, the fastest thing there is, needs 100,000 years just to cross our own galaxy from edge to edge. And our Sun holds no special place within it. It is simply one ordinary star, drifting in a quiet outer spiral arm. At the very heart of our galaxy lurks something monstrous, a supermassive black hole called Sagittarius, a star with the mass of 4 million suns, around which the entire Milky Way slowly turns. Everything you have ever known is quietly orbiting that dark, invisible center once every 230 million years. If you could shrink the whole Milky Way to the size of the United States, our entire solar system, the planets, the Voyagers, all of it would fit inside a single coffee cup. That is how lost we already are inside our own galaxy. And the galaxy, remember, is only the beginning. Our galaxy is not alone. It drags along a retinue of smaller companion galaxies, like the large and small Magellanic Clouds, dwarf galaxies of millions of stars, bound to us by gravity and slowly being torn apart and devoured. Even galaxies, it turns out, feed on one another. Pull back further. The Milky Way and Andromeda are the two giants of a small collection of galaxies we call the local group. Andromeda is a spiral even larger than our own, holding perhaps 1 trillion stars, and it is the most distant thing most people can see with the naked eye. Andromeda lies 2.5 million light-years away. The faint smudge of light entering your eyes tonight left it before the first humans ever walked the Earth, and it is racing toward us. In roughly 4 billion years, Andromeda and the Milky Way will collide and merge into one enormous new galaxy. But the local group is only a quiet suburb. Zoom out, and galaxies gather by the thousands into colossal swarms called galaxy clusters. The nearest great one, the Virgo cluster, contains well over 1,000 galaxies, bound together across tens of millions of light-years of space. And the clusters themselves are not the end. They link together into superclusters, immense chains and sheets of galaxies. Our own cosmic address has a name, the Laniakea supercluster. It is a structure so large that light would need 500 million years simply to cross from one side of it to the other. At the very grandest scale we can map, the universe stops looking random. The superclusters join into a single connected pattern, glowing threads and walls of galaxies wrapped around immense, echoing voids of near-perfect emptiness. Astronomers call it the cosmic web. And it looks, unsettlingly, like the neurons firing inside a human brain. The largest single structures we have ever found stretch the mind past breaking. The Sloan Great Wall is a sheet of galaxies over 1 billion light-years long. Some surveys hint at structures larger still, so vast that our best theories struggle to explain how they could have formed at all. So, at last, how big is all of it? The part of the universe we can actually observe, the observable universe, is a sphere about 93 billion light-years across, and inside that sphere sit an estimated 2 trillion galaxies, each one holding hundreds of billions of stars of its own. 2 trillion galaxies. There are more stars in the observable universe than there are grains of sand on every beach and in every desert on the entire Earth. Many, many times over. And around a great many of those stars circle planets. At this point, the numbers stop meaning anything. They simply dissolve into awe. The most distant objects we can see are quasars, the blazing hearts of young galaxies, shining across more than 13 billion light-years. Their light has traveled almost the entire age of the universe to reach a telescope on our tiny world. We are, quite literally, looking back to nearly the beginning of time, and there is a final wall. Look far enough in any direction, and you reach the cosmic microwave background, the faint afterglow of the Big Bang itself. Radiation from when the universe was only a few 100,000 years old. It surrounds us on all sides. It is the oldest light there is, and the edge of everything we can ever see. Here is the truly staggering part. The universe is only 13.8 billion years old, so how can we possibly see things 93 billion light years away? Because while that ancient light was traveling toward us, space itself was stretching, carrying those galaxies ever farther apart. The universe is not merely enormous. It is still, at this very moment, growing. And beyond the edge of everything we can see, the universe almost certainly continues. Perhaps for a great deal farther, perhaps forever. We may live inside a cosmos that is, quite literally, infinite, with almost all of it lying forever hidden beyond a horizon that we can never, ever cross. So come back now, all the way home. Past the cosmic web, past the superclusters, past Andromeda, back through the Milky Way, back to one ordinary yellow star, and one small blue world quietly circling it. That single world is everything you have ever known, and set against the true scale of the universe, it is smaller than one atom in an endless, shoreless ocean. And yet, on that tiny, fragile speck, matter somehow woke up. It opened its eyes and learned to look outward, to measure the distance to galaxies, to weigh the whole universe and dare to ask how big it truly is. You are one of the ways the cosmos has come to know itself. And perhaps that, far more than any distance, is the most staggering thing of all. Thank you for spending this time out here among the galaxies with us. If this journey moved you or made you feel wonderfully, beautifully small, consider subscribing and we will see you on the next one. Until then, keep looking up and stay spaced out.